This is Algebra 2 with trig, the review worksheet for 4.1, 4.4. We're first looking at recognizing the standard form to see if the graph opens up or down. Because the a value is -2, it is negative, so it's less than 0. So that means it opens downwards. It opens down. The line of symmetry, we would look at negative b over 2a, which would be -4 over 2 times a, or over -4, which is -1. That's your line of symmetry, x equals -1. And then to figure out the vertex would be located when you plug in that -1 value. So you first need to square the negative to get a positive. So -2 plus 4 is 2, so that's at 6. -1, 6 would be our vertex. For number 2, we're looking at the line of symmetry, the vertex, and some additional points. So first, this is in standard form. So we're going to look at the line of symmetry, which is -b over 2a, which is -2 over 2, which is -1. We're going to plug our -1 back in. So that's going to give us 1 minus 2 minus 3, which is -5, -4, it looks like. So we have a line of symmetry at actually x equals -1. So you write that on your graph. Then we're down at -4. We have a y-intercept at -3. And we reflect that point over the axis of symmetry. And then we can plug in another point. I can plug in 1. So when x equals 1, I would get 1 squared plus 2 times 1 minus 3, so that would actually give me 0. 2 steps to the line of symmetry, 2 steps past the line of symmetry. Remember, in standard form, we don't have to graph the parent function. For our next equation, we're looking at the line of symmetry. So x is going to be -b over 2 times a. So that gives us -2. So we have an axis of symmetry at -2. We're going to plug in our -2 back into the problem. So we're going to square the -2, minus 2 times -2, plus 7/2. Well, first we have to square -2 to get +4. -2 times -2 is +4. Half of that is -2. So it's 2 plus 7/2. So that would be 4/2 plus 7/2 equals 11/2. So that's 5.5. Positive 5.5. That would be up there a little ways. Seems to fall off. Let me check my work to be sure I'm right. First we did -b over 2a. So the negative made that positive. Half of 2 is -1. So we plugged in our -2 back into the original equation. Squared the -2. Took half of it and changed the sign. And that's what I see. So up at 1, 2, 3, 4, 5 and a half. One, two, three. So 2 spots over, 2 spots over. I'm very perplexed by this falling off the graph. And then that's opening that direction so far. We would also want to test a point, so I can test a further point. Let's figure out what happens when x is 2. So when x equals 2, we're going to get y equals -1/2, 2 squared minus 2 times 2 plus 7/2. That's -1/2 times 4. -2 times 2 is -4 plus 7/2. -6 plus 7/2. That would be -12/2. So that's -5/2. So that would be 1, 2, 3, 4 from the line of symmetry. So it would be 1, 2, 3, 4 past it. And our graph would be y equals -1/2 x squared minus 2x plus 7/2. The candy store has about 380 members and charges each member $35 per year. The owner estimates that there will be 15 more members for every $2 reduction in membership price. Write a quadratic function in standard form that models this. At what price should the store sell the membership to maximize profit? So we're looking at our revenue is going to equal the number of memberships times the price. So our revenue, the number, well at this point, the number of memberships, there are 380, and that's the price at $35. So using our calculator, we'll take 380 and times that by 35. So we're going to get 13,300. Now every time I reduce the price by $2, we're going to get 15 more people. So we're getting 15 extra people for every reduction in price. So if I take the 380 and we get 15 extra people and we times that by the $35, removing 2 of that, we're going to have a lower price already. Perplexed again. Let's be sure I did that right. $380 at $35 $15, or there will be 15 more memberships for every $2 reduction. So we reduced it, we got more memberships. Alright, that's what it is. So we have 380 plus 15 for every X, and 35 minus $2 for every X. And we're supposed to write this in standard form. That means we're going to multiply that together. So we're going to take the 35 and times it by the 380 like we already have, and we got our 1330, or 13,300. 760 our 15 times 35 gives us 525, and 2 times 15 gives us negative 30. So then we collect our like terms. That should be 525x. Collect our like terms gives us negative 30x squared. We have the 525 subtracting the 760, which gives us negative 235. And the positive 13,300. That is our function. And at what price? Well, that would be our line of symmetry. We need to, or the maximum value, but we need to find the line of symmetry. So the line of symmetry of this, we could use this right here to find our P and the Q. So we'll take our 380 plus 15x and equal that to 0. Subtract that across. Divide by the 15. So we'll take our negative 380 and divide that by our 15. And that's going to go in there negative 25 1/3. So that's actually negative 76 over 3. Okay. Then our other one is going to be 35 minus 2x equals 0. That's negative 17.5. So with those two values, what we're going to do is take the average of those two. So we're going to take our negative 76 divided by 3 and add that to our 17.5. Divide that by 2. So our line of symmetry is almost at 4. See if I can get the exact numbers here. Negative 76 divided by 3 plus 35 divided by 2. That would be the 17.5 divided by 2. Looks like 6 would be our common denominator. So double that. 152 over 6. 70 or times 3 this time. And we'd still have 2 over here. So that's going to be 47. Negative 47 over 6 divided by 2. So that's negative 47 divided by 12. Let's see if that's the same number I just came up with. So negative 47 divided by 12. Bingo. So that's the negative 3.916. That's not the price, alright? That is our line of symmetry. And then we take that value and we plug it back into the equation. This is a pretty messy question. But okay, we're doing just fine. So I'll show you a trick that we can do if we were using a calculator for this one. We could take our, since we have the answer here, we could take the 380 and we could add the 15 times that answer and times that to the 35 minus 2 times that answer. So we're going to have a maximum value of 13,760.20, almost 2,1. You will have one like this on your test, but it won't be nearly as sloppy. It won't have the fractional values for the line of symmetry. Sorry about that. Here, this is vertex form, so we're going to have to do the parent function. So that's y equals x squared. And then there's no reflection. There's no stretch, but there is a translation. So we'll take each one of these points and we will translate 1 unit left, 2 units down. Oh, I'm sorry. This is 1 unit to the right. It's always opposite of what's inside the parentheses. So 1 unit to the right and 2 units down. So now we have our new parabola. Y equals x minus 1 squared minus 2. Here we start with our parent function. So that's y equals x squared. This one has a reflection. So we're going to flip it over the x-axis. 4 above it. So we go 4 below it. So that was the negative. That's y equals negative x squared. There's no stretch because there's no other number in front of the parentheses. So there's just a translation. We're first going to reflect over the x-axis. And then we're going to translate 2 units left. It's left for sure because of the opposite of what's inside the parentheses. 1 unit down. And our equation for that would be y equals negative x plus 2 squared minus 1. We're going to find the minimum or maximum value. Here this is in vertex form. So x is going to equal negative 3 for our line of symmetry. The vertex is going to be at negative 3, negative 2. It opens down. A is negative 8. It's less than 0, so it has a maximum. So the maximum is at y equals negative 2. Be sure your answer is y equals. It's not a vertex value. This is an intercept form. So first we have to figure out the line of symmetry. So to do that we have to do our p plus q divided by 2. Our p equals negative 4. The q equals positive 5. So we're going to get 1/2 for our line of symmetry. It's going to make it a bit sloppy. So to calculate your y value at that point, you plug in the 1/2. So this would be 8 halves makes 4. And 10 halves makes 5. So this is 7 times 9 halves. And this guy here is negative 9 halves. So to calculate that out, we would multiply the two fractions, which would give you negative 81 over 4. And then for us to multiply the 81 times the 7 gives us 567, negative 567 over 4. So divide that by 4 and we're going to get our 141.75. That's our y value. And that would have to be negative, of course. We know that with this equation, the a value is equal to 7. So the a value is greater than 0. So we know this has a minimum value. If it has a minimum value, it has to be opening upwards. So it has a low point. So I knew I couldn't be way up at 141 opening upwards because it would never touch the x-axis. But I know this touches the x-axis at 2 spots. Solve the equation. We need to figure out the value of x. So one way to solve the equation is by factoring. So notice that the a value is greater than 1. So we're going to have 12. What multiplies to be 12 and adds to be 8? We know that both numbers have to be positive. For it to add to be positive and multiply to be a positive. So looking at our factors, 2 and 6. So one way we could do this would be with the box method. Using 3x squared and 4 in their locations with the 2x and 6x. Factor out what you can. So you have 3x plus 2 times x plus 2, and you can check that by foiling, equals 0. Zero product property will give you negative 2/3 and negative 2. With this next one, notice that it doesn't equal 0. So I would suggest to keep the x squared positive. So let's add the 23 to the other side. Add the 30 to the other side. So it's 0 equals 3x squared plus 23x plus 30. Now, because there's no GCF that can come out of this, we'll multiply the 3 times the 30 and get 90. That adds to be 23. So again, both numbers are going to be positive. Running through all of our factors. 4 doesn't go into there. 5 is going to go in there 18 times, which gives us that 23. That's kind of a tricky one. So you could use the box method. I'll show you factor by grouping. 3x squared plus the 5x plus the 18x plus the 30. That should equal 0. Circle your two groups. Factor out your x. Bring down your sign. What can go into 18 and into 30? It's 6. Notice what's left inside the parentheses. 6 times 3 is 18. 6 times 5 is 30. So what's inside the parentheses are exactly the same. So we bring down our x, we bring down our 6, and then we bring down the 3x plus 5. You only have to bring that down once because both the x and the 6 are multiplying that like FOIL would do. The zero product property will give us negative 6 and will give us negative 5/3. Our story problem. The dimensions of an old sandbox at my apartment is 12 feet wide and 10 feet deep. The new mega sandbox will have twice the area. The dimensions of the new mega sandbox were created by adding the same value x to the length and the width of the sandbox. What is the value of x? So we have the original sandbox, which was 10 by 12. Now we're going to make the new sandbox even bigger. So we're going to say x plus 10, and we're going to say x plus 12. So this area originally was 120. This would be twice as big, so this area is 240. So what's the value of x? X plus 10, x plus 12 has to have an area of 240. X squared, 12x and 10x plus 120 equals 240. Subtract the 240 across so we can make it equal 0. 12 plus 10 is 22x, gives us negative 120. So now we want to see what multiplies to be negative 120 but adds to be 22. We know that the two signs have to be different and the larger number has to be positive. So going through all of our factors, with it being 120, there'll be quite a few of them, but we're pretty close already. That seems to go into there 2 times let's see what our numbers are here. So as we look to our different factors, we see that nothing here is adding we have negative 6 and 20. None of these are adding to be a positive 22. So this is actually prime. We wouldn't be able to solve the problem using this method, factoring. It's not factorable. So the quadratic formula would be used to solve this, not factoring. We'll pick that up at a later date. We're going to write the equation in intercept form. So to do that, we're going to factor this. Notice that this has 2 terms to it. It doesn't have the third term. So the best thing we can do is pull out the GCF. So that's x plus 3. So that would be actually intercept form. It would cross at 0 and it would cross at negative 3. Here, to put this into intercept form, it doesn't have a GCF. We'll get negative 36, positive 5. So you know that the two signs have to be opposites of each other, and the larger number is going to be positive because it adds to be a positive. So we go through our different multiples that could possibly go into there, and we get negative 4 and positive 9. So using the box method, you could use factor by grouping if you like. Factor what you can out of the bottom, factor what you can out of the top. So that leaves us with 3x minus 4 and x positive 3. If we multiplied this back, we get 3x squared, 9, and negative 4 gives you positive 5, negative 12, just to check. So that would be our intercept form. There is no number we can factor out to give a different a value. Enjoy.